Welcome to AI Frontiers. This episode explores CV breakthroughs unleashed, synthesizing 80 papers in computer vision and pattern recognition from October 7th, 2025. This presentation overviews the visual AI revolution, a snapshot of 80 papers from one explosive day on the arXiv preprint server is dived into, all focused on computer vision. Themes, findings, methods, and key papers are explored to reveal how AI transforms everyday technology. A narrative journey from Fog Unite drives to 3D room models is prepared, blending insights for enthusiasts and professionals. By the end, the big ideas shaping the future of visual intelligence are grasped. Computer vision and pattern recognition are understood as the AI subfield dedicated to teaching machines to interpret the visual world. Machines are given eyes and a brain to process images, videos, and 3D data, such as recognizing a cat in a photo, tracking a ball in a soccer match, or generating a new scene from a text description. At its core, patterns are spotted in pixel data, including edges, shapes, and movements, to extract meaning. This field underpins self-driving cars that navigate traffic, medical tools that spot tumors in scans, and apps that augment reality with virtual overlays. In the broader AI ecosystem, computer vision stands as a powerhouse, replicating the 80% of human information obtained visually, which unlocks smarter robots, better surveillance, and creative tools like AI art generators. With the rise of deep learning, the field has boomed, yet challenges persist, such as noisy data, limited compute, and ethical concerns like privacy in facial recognition. These 80 papers highlight progress in handling real-world messiness, from low-light scenes to multimodal fusion, evolving computer vision from static image analysis to dynamic world-understanding systems. Research themes begin with diffusion-based generative models, sculpting reality from noise. A key theme involves diffusion models that start with random noise and iteratively refine it into high-quality images or videos. These models are used in thermal image restoration and limited-angle tomography, as in the work by Deng and colleagues, to fix blurry or incomplete data. Realistic synthesis is enabled, such as video generation or facial aging, with effective handling of uncertainty. Evidence from multiple papers positions diffusion as the go-to approach for diverse, crisp outputs. Diffusion-based generative models extend to applications and innovations. These models are applied to 3D reconstruction and even breaking image watermarks, revealing security vulnerabilities. Papers demonstrate iterative denoising for medical imaging and anomaly detection. The core idea revolves around reversing a noise addition process, akin to chiseling a statue from marble by chipping away imperfections. This ties into broader computer vision progress by enhancing fidelity in noisy real-world scenarios. Multimodal integration blends senses for richer AI. Another dominant theme fuses vision with text, audio, or other data types for comprehensive understanding. Examples include the Lumina Daimu model by Shin and colleagues, which unifies text-to-image and audio casks in one framework. Video summarization and segmentation are improved, such as describing a scene, like the red car speeding left, and having AI segment it perfectly from footage. Relevance is found in adding ears and a voice to computer eyes, enabling unified models for complex tasks. Efficiency and real-time processing speed up visual AI. Focus is placed on lightweight models for devices, crucial for real-time applications like drones or phones. The work by Chen and colleagues achieves 15 frames per second in 3D reconstruction from monocular videos, cutting compute costs with techniques like superpixel segmentation or rasterized mixtures of experts. Practical deployment is addressed, making computer vision accessible beyond supercomputers. Key findings reveal aha moments from the papers. Diffusion models can erase robust image watermarks almost completely, dropping detection rates to near zero while preserving visuals, as shown in various works. Autoregressive models now rival diffusion for 3D point cloud generation, achieving state-of-the-art quality on dense sets with progressive detailing, potentially speeding up VR content creation by factors of 5. Real-time multi-human scene reconstruction is unified from monocular videos, with models like Human 3R outputting multiple people, environments, and camera paths, slashing errors to under 10 centimeters, and enabling AR apps on everyday devices. In medical imaging, hierarchical transformers boost liver cancer subtyping accuracy by modeling multi-scale features, outperforming baselines, and aiding personalized medicine. Geospatial fusion of LiDAR and radar creates global forest maps with 0.82 R² accuracy using tiny models, revolutionizing climate monitoring without supercomputers. Anomaly detection benchmarks in real logistics drop top models to 57% effectiveness, highlighting the need for variability handling AI in supply chains. These findings serve as bridges to practical, impactful technology. Methodologies are synthesized across the papers. Diffusion models reverse noise for generation and restoration, excelling in handling uncertainty and producing diverse, high-fidelity outputs, though they remain compute-intensive and slow for inference unless optimized. Transformer architectures use attention to process patches or sequences, capturing dependencies and fusing multimodal data in video understanding. With strengths in robust generalization from pre-training, but limitations in being data-hungry and prone to noisy attention, requiring filters for interpretability. Transfer learning and fine-tuning adapt pre-trained models like vision transformers for new tasks, offering efficiency and quick wins in face recognition or defect detection, while reducing bias inheritance with care, yet carrying over original flaws if domains mismatch. Synthetic data augmentation generates fake examples to train on scarce real data, vital for nighttime vision or medical applications, but requires validation to ensure synthetics mimic reality and avoid model failures in the wild. Unsupervised or weakly supervised learning, such as pseudo-labeling for LiDAR segmentation, cuts annotation costs and scales to huge datasets, though noisy labels can propagate errors, necessitating refinements like contrastive losses. Selected research papers spotlight the first one, limited angle tomography reconstruction via projector-guided 3D diffusion by Deng and colleagues in 2025. This paper is selected for innovating in 3D reconstruction from incomplete data, impacting biology and materials science. Diffusion is used to fill missing wedge gaps in transmission electron microscopy without needing ground truth data. PSNR and SSIM are boosted by 10 to 20%. Democratizing TEM for nanoscale discoveries. The method TEMDiff operates directly in 3D, denoising noisy projections iteratively, guided by a projector ensuring consistency with limited angles, tested on simulations with angles as low as 8 degrees and real data, showing stellar generalization without retraining. The second selected paper is Human 3R, Everyone Everywhere All at Once by Chen and colleagues in 2025. This work is chosen for real-time unified reconstruction of multiple humans, 3D scenes, and camera paths from monocular videos, all in world coordinates. It represents the efficiency theme, enabling AR and VR on everyday devices with 15 frames per second output on 8 gigabytes memory. Errors are reduced to less than 10 centimeters, rivaling specialized tools and simplifying immersive tech and robotics applications. The approach adapts CUTR with visual prompt tuning, adding lightweight prompts to extract SMPLX bodies while suppressing dynamics, trained briefly on synthetic bedlam data. The third selected paper is Lumina DMU, an omni-diffusion large language model for multimodal generation and understanding by Shin and colleagues in 2025. This is highlighted for unifying multimodal tasks in one fully discrete diffusion model, novel in integration. Data is tokenized for discrete denoising, integrating an LLM backbone for sequences, trained for diverse tasks like text-to-image, editing, and understanding. FID is improved by 15% with faster inference, advancing AI assistance for creation and editing. It exemplifies the theme of blending modalities, inspiring on-device robotics and tools. Future directions point to what's next in computer vision. Tighter multimodal fusion with reinforcement learning is expected for embodied AI, such as robots learning from vision-text pairs. Ethical pitfalls are addressed, including robust defenses against watermark breaking and deepfakes, alongside data scarcity pushing synthetic validation. Lightweight models for edge devices and benchmarks for real-world robustness are anticipated. Interdisciplinary applications emerge, such as satellite computer vision for climate monitoring and deforestation. AI synthesis and review explain how this deck was created. Content is synthesized using AI tools, including GPT-Grok with model Grok 4.0709 for generation. TTS synthesis is handled via OpenAI for audio, and image generation uses Google for visuals. Review by a human expert ensures accuracy and coherence. Potential oversights may exist, with all references provided for verification. Subscribe to the AI Frontiers community. Subscription to the YouTube channel is encouraged for more deep dives into AI research breakthroughs. The channel title is AI Frontiers. The description highlights staying updated on the latest papers and innovations. Hit subscribe now. In this podcast, the latest breakthroughs in computer science and AI are brought straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so staying ahead is possible. Whether a developer, researcher, or tech enthusiast, AI Frontiers keeps informed daily. Thanks for listening. If this episode was enjoyed, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXivpreprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXivpreprintserver.org.